Hi, welcome to Lean Blog Interviews. I'm your host, Mark Graban. Our guest today is Dr. Melisa Buie. She is an experienced leader in operations, engineering, and manufacturing transformation. She's worked in senior roles at companies including Lam Research, Applied Materials, and Coherent, where she spent over 15 years solving problems and making lasers. So that's kind of a cool thing. So before I tell you more about Melisa, thanks for joining us on the podcast. How are you?
I am well. Thanks for having me, Mark. Appreciate being here.
Yeah, we'll probably talk more about your operations and lean and leadership experience than the lasers, if that's all right.
That's perfectly fine.
Okay. Melisa has a PhD in nuclear engineering and plasma physics from the University of Michigan. She taught material science at San Jose State University for a decade. Melisa is a Six Sigma black belt and has co-authored over 40 journal articles and publications and holds 6 patents. And I think some of the things we will talk about today include 2 books. She's the author of Problem Solving for New Engineers, and also the upcoming book coming out later this year called Faceplant, Free Yourself from Failure's Funk. And with Problem Solving for New Engineers, you had some co-authors to that book, right?
No, that was a solo publication. Yes,
That was
so
solo.
Faceplant's the co-authors.
Well, I just demonstrated a faceplant. Unintentionally, but okay, no need to edit that out. The solo book, Problem Solving for New Engineers. So before we talk about problem solving and some of the things you've done in your Melisa, I love to ask people, their lean origin story, or maybe it was a Six Sigma origin story. I'd love to hear, some of the, why, when and where and why and how you got involved with improvement.
Yeah, so my introduction to lean was through Six Sigma. Mm-hmm. So I started out as being really curious about all the statistics and learning that as a math major. I was super excited to know that we could apply that in industry. And so ended up doing a green belt and then a black belt and did some really cool projects, saving a ton of money. But our company decided at some point that we were going to go in the direction of lean and really invest in having a lean culture. And so I was like, well, I know lean. I did that Lean Six Sigma thing. And it was like, well, there was like 2 minutes of lean in the whole Six Sigma thing that I studied.
That's I started typical. Yeah.
Yeah, so I started doing a lot of reading and was really, really surprised by the, not necessarily the tools, but the people side of lean, and really fell in love with it after starting to really engage.
Yeah. Do you remember, which books were some of your early influences in your education and what inspired you?
I will tell you a book that I've read multiple times and still go back to as a reference is Katie Anderson's Learning to Lead, Leading to Learn. And not necessarily because it teaches a whole lot of lean tools. That's not why at all. It's really this learning to, like, this power of reflection and having someone be so brave and talk about their failures. I found that to be just eye-opening, and it was so impactful to me.
Yeah. So, I hear you talking about, the shift from projects to culture, cost savings, maybe to a broader focus. Like what could you sort of paint the picture of like where that push was coming, from? Was it coming from senior leaders that were taking the company in that direction of looking more at culture?
It's interesting. With Six Sigma, it's very project based, right? You have this, you gather this team, you have a project that you're working on, and it's like this big thing. Um, and then there's a very formal process that you go through. With Lean, it's like you're just making things better every day. And I
Mm-hmm.
think that was a big part of what we were trying to communicate. And it wasn't like, oh, you need all this extensive training to learn Lean or to
Mm-hmm.
practice Lean. You just need to start making things better and like give your team permission to make things better and permission to say, hey, you know what? I found something that we could do better.
Yeah.
And not like, oh, bad for pointing
Mm-hmm.
out some failure. And so that I just became fascinated with that culture shift um, between, this project mentality and just like, okay, well, let's just do. I mean, 2 Second Lean was another book that really just, we
Yeah.
got
Mm-hmm.
copies for everybody because we wanted them to know, hey, just spend a couple minutes and make things better.
Mm-hmm. Yeah. So Paul Akers, author of 2 Second Lean, like Katie, a guest on the podcast, and people can go search past episodes, if they want to hear those discussions. I mean, what was your role in the organization when you were having this awakening, to lean? And I mean, if you were, in senior roles, you were probably one of those people that was helping influence
Yeah,
culture, right?
yeah. So what we did, which was a really, so I worked for Coherent when this was taking place.
And was that
And
semiconductors also like Lam and Applied Materials?
Coherent is a photonics company. So we make lasers at Coherent, or
Okay,
they
so
make lasers.
we're going to talk a little bit about making lasers. Here we go.
So, yes, so Coherent makes lasers. I think now they're considered a material science company, so
Mhm.
lasers is a part of what they do. But yeah, so I was director of operations as my starting role,
Mhm.
and our VP of operations held what was called a global operations conference, and he would pull together people from all of our operations sites around the world, and we had 25 at the time, and we would pull them together, and we formed a uh, operations council with that, and then we did a steering committee that really focused on lean as
Mhm.
a part of that and figuring out what we're going to do. And that steering committee, so I took on various roles throughout the company. And after that, and my next role was really leading the steering committee for North America and then stepping into the global leader for lean for the company.
Yeah. So, a lot of companies, talk about, in the context of lean, SQDC, safety, quality, delivery, and
And
cost, as
cost,
opposed
yes.
to cost focused projects. How did that evolve when, in the context of lean, when you were there, Coherent? Did it help kind of drive a broader view of what the different benefits of improvement should be?
You know, we had a strong safety culture to begin with.
Mm-hmm.
And so, and making sure that our people were safe was a big priority for the leadership. That was, and even though we had sites all around the world, we wanted to make sure that we had a safe organization for people to work in. And I love that safety's first,
Yeah.
and so and then delivery, right? Delivering to
Mhm.
our customers, making sure that they're um, they're number one. So it was, I don't know that that necessarily had a huge, that piece of it had a huge impact on the difference that we operated. That's the
Mm-hmm.
way that was a big part of our culture anyway. And
Mm-hmm.
so it made lean a lot easier for us to adopt because we were very focused on those metrics to begin with. And even though cost was a big part of it, it was still like, okay, well, let's make sure first got these other things in order. So yeah.
Yeah. Yeah. So maybe then, with that foundation of that culture, lean might have resonated in my experience anyway. The idea of improvement. We can leave the word lean out of it, and we ask people, well, what inspires you to participate in improvement? Giving people, other approaches, or like you said, giving them permission to improve safety and quality in delivery leads to lower costs. I mean, that's the thing I love. SQDC doesn't leave C out of it, not at all.
Right. Yeah, it doesn't at all. It's still important. We don't have jobs if we're not making money. So
Right.
that's still a very big part of it. And
Mm-hmm.
saving money was always important, but having a good, strong culture was what we focused on. And then as a result, we were able to save money.
Yeah. Could you elaborate a little bit on, kind of, so your experiences in working with people, as you put it, giving people permission to change? Like, and some people ask, well, why do you have to do that? Like, well, I don't know how much of it was the history where you've been working before, but it's pretty common where people get told, some variation of, well, just do your job, be quiet, don't be a troublemaker, and they stop trying to improve. So how do
That
you
is
how do you
true.
help open up that permission?
We had so we focused on providing training, and training seems to be too formal of a word. It
Mm-hmm.
was it was very much like engage with every employee so that and have conversations with them so that they could feel like they had permission to express themselves and really make a difference for the company. And, we talked about the importance of what we did and the impact that it had in the world. And, this was our purpose, right? We were very much in touch with that.
Mm-hmm.
And being able to provide the value that we did to the world was a big deal for us. And so we wanted to make sure that everyone had that. And that's the kind of center why that they were working from.
Yeah. Um, One of the things, I just want to ask a little bit, as part of your origin story, a PhD in nuclear engineering and plasma physics. I wouldn't pretend to know anything about nuclear engineering. I don't even know what plasma physics is. I imagine that was a pathway into semiconductors and materials, and like just from a academic to professional bridge. That's how you ended up in that industry.
It is. And well, actually it started with this big goal, right? Like this was back in the 80s, and I'm dating myself, but we were very concerned about energy. And this is my friends and we were very concerned about energy and the energy crisis and what
Mm-hmm.
was going to happen. And there was a lot going on, a lot of discussion about energy. And, to have this safe, clean energy source that um, was proposed, fusion, and we wanted to all be a part of that. And fusion was taught in the nuclear engineering departments. So yeah, we were very engaged and firm disciples for fusion energy. And it turned
Wow.
out that it was always 25 years in the future. And when I started, it was 25 years in the future. And when I finished school, it was still 25 years in the future. And we still don't, we've demonstrated it, but we haven't, we don't have any working fusion reactor plants in the world. So it's still in the future someplace, but
Right.
that was it. It was like, let's solve this big problem. Let's go after it. So I loved being involved and engaged with all these people who are very passionate about solving this big problem.
Yeah. And in that time frame, I mean, that was really part of the boom in semiconductors and computers. And
Yes.
I know Applied Materials makes equipment to help make chips. Is that also also true with Lam Research, that these are like suppliers to Intel and other semiconductor companies?
Yes. So Lam Research and Applied Materials are two semiconductor equipment manufacturers, and they supply to the Intel, Micron, Samsung, TSMC
Yeah.
around the world. Yeah.
Yeah. Yeah. And so you ended up, so was there kind of that bridge from energy into semiconductors, or was that just also kind of like, after working on fusion and having those interests, semiconductor was a good industry to become part of, for like for
Well,
you personally, professionally?
so it turned out that um, so fusion uses plasma. So since I was studying plasma anyway, it turned out that it was just during that time when the semiconductor industry was hitting it
Mhm.
off, right, getting really big, and they were starting to adopt plasma reactors, these kind of tabletop plasma reactors in the industry to make more uniform computer chips. And so I ended up with a scholarship from like an IBM manufacturing scholarship and for my PhD. And so I kind of did a left turn and
Mhm.
went into semiconductor manufacturing, and that was what I studied for most of the time.
Yeah. And I know Intel, I think for a long time has been really focused on Lean and Six Sigma, to varying degrees. And one other question I wanted to ask before we kind of shift to talk about problem solving in the book. Did you run across any of the challenge or the pushback where people say, well, what we do is very complicated. We don't build cars. We're not building 1,000 a day of something. Like, were there struggles in trying to get people to help translate, from automotive origins into semiconductors?
You know what? There is a huge there's definitely something that we have to shift in our mentality when you're talking about really high volume manufacturing versus what we do, whether it was in the semiconductor industry or in the laser industry, where it's low volume, high mix
Right.
type builds, and a lot of it's very custom. So very expensive equipment that you're supplying, and these, even though it's not volume, there's still a lot of the principles that
Mhm.
apply to our industry, to that type of manufacturing.
Mhm. Yeah, especially then, when as you were describing, you're focusing on culture. For the most part, people are people. Large organizations have certain dynamics, and I think problem solving is one of those kind of universally applicable or transferable practices. Take books written on Toyota problem solving, and smart people working in other industries, whether that's semiconductors or healthcare, like you're smart, you can figure out how to apply this or adapt it to your own setting. So hopefully, there's
Right.
more of that. But let's figure out how to apply it, as opposed to people playing defense and saying, well, no, we're different.
Yes. It is, it's interesting. I've worked with lots of different people and talked to a lot of different people, especially with involvement in organizations that really look at lean and what's going on with lean and share best practices. And I can learn things from the food industry and from, you know, the chemical industry and still bring those home and apply. It may not look the same as what they're doing in the food manufacturing, but yeah, it's broadly applicable, the principles and some of the tools, maybe not all the tools, but some of them definitely.
Yeah. So let's bridge to talking about the book and Melissa's solo project, problem solving for new engineers. I'd love to hear. I always like to ask authors of the story of how a book came to be, but maybe first question is to explore the bridge from giving permission to improve, permission to change, and where in some settings that might not be enough. Like, okay, we have permission to change, or we have permission to point out problems. So now hopefully that leads to problem solving. I would argue permission's important, but maybe not enough. Or you could frame it as psychological safety is related to permission plus effective problem solving. I see you nodding. Can you kind of talk about like how that flows together? If someone's got a gap in the problem solving, that's where a book like yours comes in, perhaps.
Yeah, I'm so glad that you and others are doing so much work and spreading the message about psychological safety, because it's such an important concept. And in a lot of times, we want to make sure that our jobs are safe, and we don't want to do anything that's going to rock the boat. And even if people say, oh yeah, it's okay to make changes, it's okay to point things out, it's really up to the leaders of the company to make sure that people indeed feel safe. One of the stories I love is that if somebody brings up a problem or highlights a problem in a Toyota plant, the manager will say thank you.
Yeah.
If they pull that andon cord and stop the line, the manager says thank you, right? They're not passing those defects on. And that's what we need to, we've got to learn to not freeze and, hesitate and just really, truly embrace that the only way we're going to get better is by making people feel safe enough to really make those changes and to highlight when something isn't working.
Yeah. Yeah. What I hear you saying is, the actions of leaders have to reinforce what they say, right? So I think sometimes there's a saying versus doing gap. We say we want you to speak up, but then if we react badly when people do, they'll stop speaking up, right?
Right. Yeah. We're trained very early on that failure is not okay, that, pointing out mistakes, and, you get embarrassed in kindergarten, you get embarrassed in first or second grade, right? Like anytime you make a mistake, right, it's a huge embarrassment. We don't celebrate that. And so we've got to retrain ourselves to think about these mistakes and failures in a different way.
Mm-hmm. So there's an additional preview or the connection to when we'll talk about the upcoming book about face plants and failures. And I love the subtitle. Again, that book is Face Plant, Free Yourself from Failure's Funk. There's some nice alliteration going on there.
It was intentional.
Yes. But tell us how the problem solving book came to be, kind of like the spark or the origin of taking on a project like that book?
Well, so problem solving for new engineers came to be out of my teaching. And so I was teaching at San Jose State, typically like one or two courses. I was an industry teacher. And so I'd come in and I'd teach a class. And at the same time, I was an engineering manager, director of operations throughout in industry. And I hired in my various roles, I hired a ton of new engineers, new college graduates into industry. And one of the things I realized is that our expectation in industry is that these new engineers come in and we want them to solve problems. We want to be able to say, hey, here's this problem, go solve it. Mm-hmm. But we didn't prepare in university, we weren't preparing our new engineers to do anything like that. If you think about the university labs that we participate in, and I'm not blaming this on universities, they teach a lot of stuff and they've got a lot of subject matter, that expertise that they need to communicate during those 4 years. They've got they've got us captive, right? So what I realized is that we have a very prescriptive, almost like a recipe that we follow when we're in our university labs, when we're supposed to be learning problem solving. And what they do is they tell us, pay attention to this, what color is that when you do this, look at this thing. And when you're solving a problem, you don't know necessarily what to look for, where to look. You've got to go in and, eyes wide open and start making observations. And so what I wanted to do is talk to this missing piece, this gap between what we want in industry and what's happening in our universities. And I wanted to provide a tool that would say, hey, here's like some important things that you may not have gotten out of your university courses, your university labs, that will bridge that gap, because you've got all this knowledge of subject matter. You're bringing that into your job, and we want that. But now we want to, point out all these other things that will help you to solve a problem. And that's how it came to be. I actually taught a class, taught it several times, and my lecture notes were kind of the origin of this.
Okay. So you talk about bridging from laboratory settings, and we're doing experiments, and I wonder how much of it is like when students transition to the workplace, do they get taught new habits that replace the old scientific thinking, experimental process? So I think of like workplaces, leaders, often crave certainty. Like, propose something to implement that is going to work. Like, that sounds like the opposite of an experiment, right?
Right. Yeah, I think we, young people, young engineers who come into industry and are trained on problem solving and are given the opportunity to learn problem solving, they are very, very lucky. And I think they are the minority over the people who come in, and it's really trial by fire. And, you pick it up over time, you learn it. There's a lot of OJT, on the job training, that takes place at all levels in many, many organizations. And so I think we do our young people, our young engineers, a disservice if we don't provide some type of guidance and some type of learning for them. But it is very rare, from my experience.
Yeah, yeah, yeah. Sadly, yeah, I agree with you. Sadly, it would be the exception, I think, rather than the norm. Now, maybe the odds are higher today in 2025 that a new graduate takes a job at a company that's embraced lean or Toyota Kata or whatever language they're using around experimental problem solving. That might be higher than the odds. I'm going to date myself. I graduated from college 30 years ago this month. It was probably even more rare at that point to have a company that embraced this experimental mindset I mean, to me, that's PDSA cycles. As Dr. Deming was teaching long before then, but I think it's rare when companies really let people follow that type of cycle and iterative approach to improvement. And I'm curious how would you kind of explain this need to go through cycles? Like, how do we find the balance between not just randomly, wildly trying any old thing, but having a good hypothesis and thinking like a scientific problem solver?
It's interesting because I run into so many young people who are like, well, if I don't control everything and just vary one factor at a time, I'm going to be, I'm going to confound everything. I'm going to confuse everything, and I won't really understand what's going on. Mm-hmm. And so because they haven't learned how to design experiments. This is not something we teach, right? Our labs are very prescriptive. They have the quote unquote experiment that you're supposed to run. Typically, it's not an experiment; it's a recipe. But we're following. We have to follow these steps to create whatever it is that we're paying attention to. And with experimentation, you are really, like, there's a whole bunch of stuff you need to understand around experimentation, particularly around variation. And and there's some basic math that you need to understand. And so, but once you've got that, once you get these concepts, and they're not like crazy complex, but once you understand those concepts, they are very, it just frees you up to do so much. And the experiments that you can run, once you understand how to manage variation in different problems, it's like, I don't know, it just takes you to a whole new level. And when I first learned about how to actually design an experiment, which, by the way, was after my PhD, when I was in industry, it was a whole new world that opened up. It was like, I really felt like I'd entered a new paradigm. And I look back at my one factor at a time experimentation for my PhD and master's, and I'm like, oh no, but that's the way we learn. That's where we start. So
yeah, and I think this is a phrase somebody in the Toyota Kata community said, and I think it makes so much sense. They said, if you know the outcome of what you're doing in advance, it's not really an experiment. And you're making me think back now to, in particular, high school chemistry class. I took chemistry in college. But that's a really good call out that students, it would be irresponsible for the teacher to let you run an experiment that really had a wildly unknown outcome, right?
Right. It's not the fault of our universities. They're doing the best they can and they're keeping our young people safe so that they get degrees and come into industry.
Yeah.
But yeah, it is very different.
And I mean, I think of nuclear experiments back in the day from, Oppenheimer or films. I didn't see Oppenheimer, but there was another film that was more of a documentary about Manhattan Project era, and some of these experiments where people died. Maybe
Yeah.
there was a mistake made in the experiment, or something wasn't known to be as unsafe as it turned out to be. I mean, that's really a different environment, and maybe you know better or appreciate some of the history there of like really groundbreaking and therefore risky experiments versus workplace experiments where hopefully we're not as it's not as dangerous.
So far, I've been very lucky. I have not participated in experiments that were life-threatening or that could, risk life or limb. So I'm good there.
Yeah.
But certainly in industry, we try to keep our experiments very, very safe, and it's yeah. So the young people get to experience what it's like to discover something, and even if it's new to them, it's a discovery. And I even
Mm.
advocate like taking something where maybe you do know what the outcome is going to be, but you want to kind of discover it for yourself.
Oh,
And
okay.
that's an amazing thing, right? Even if you take one of your basic laws of physics
Yeah.
and do some and discover it for yourself,
Yeah.
it's like, oh wow, you will never forget that. You will never forget it. When you run an experiment and you prove something physically,
Mm.
it's a really great feeling.
Well, and so there's the counter to okay, so running an experiment that's new to you can still bring learning or
Mm-hmm.
inspiration or excitement. So there's some okay, so that's not a bad thing then, I guess, to run an experiment with a known outcome if it's for the purpose of learning.
Yes.
And
And
so
you're discovering it for yourself. And
yeah,
that's when we discover things ourselves, we're so much more um, uh, we own it in a different way.
yeah. And so now I'm thinking of like lean circumstances where like somebody who's experienced or an industrial engineer can look at certain situations and pretty well know, like if we run an experiment of cutting our batch size in half, that we're going to improve flow and reduce cycle time. So we could tell people to cut the batch size in half, or we could frame it as an experiment of let's see what happens if we cut the batch size in half. And then that might inspire someone to say, well, what if we cut it in half again? And then they might hit a frontier where now, because the setup time is too long, cutting it in half again causes a problem. But I hear you advocating for there's this that's really making me think about like the benefit that comes from it's new to you. I like the way you stated that. So can you think of examples in lean practice where it would be helpful to have someone set up and run an experiment that you might kind of predict the answer to no?
Yeah. So I will tell you one of the most. This is a really simple example, but it's one of the most beautiful examples. I was visiting a company that's well known for their lean practices. And I went to, and they had their manufacturing set up in U-shaped cells. And this one particular cell, they were short a person in for that particular day. And
Mm-hmm.
the group leader, who didn't have a PhD, didn't have, I don't know what degree this group leader had, but it's like, okay, well, I'm short people and I've still got to produce this line. So I designed this experiment to figure out if we could still meet our, quota for the day. And then, she picked up the piece of paper and said, okay, here's the way we've reorganized the line because we're short people so that we can get all of this, the same throughput. And I just was like, oh, wow, that's something I would never have thought of. I wouldn't have worded it that way. And yet, she was completely discovering for herself if this was going to work. And she had permission from the leadership to run the experiment.
Yeah. And I guess leadership was willing to accept the risk of the experiment not working out.
Right. They knew they were short. So if they would have kept things the way they were, where, everybody was in their assigned positions in the U-shaped cell, they wouldn't have met their production for the day, right? So this was an opportunity to take a chance, try something new.
And you talked earlier, Melissa, about maybe this ideal of only change one variable at a time. So we're trying to understand cause and effect. Is that always? I mean, how practical? In complicated or pressured situations, are there times where you're limited, where you say, "Gosh, we can't afford the time it would take to do one variable at a time," or is that maybe counterproductive? If we say we're in a rush, we have to change three things at a time, is that really short change or undercutting our ability to improve? Perhaps, like how strictly do you hold to that idea of one variable at a time?
Well, for me, I would prefer never to have to run a one factor at a time experiment. I want to discover as much as I can about the process when I'm running the experiment. So I would want to take a look at everything that might be impacting the factor that we're trying to improve. And I'd want to look at all of those things and just see if we were optimized. And it's a mathematical tool called design of experiments that allows you to look at multiple factors and vary those so that you can see what the response is. And then you can build a mathematical model that describes that process space. And I'm a total geek, so I love doing that kind of thing. And that's the kind of experiment I want to run, is when I'm just given free rein and said, okay, well, go take a look at that. Because you don't know if there's going to be, if there's going to be interactions that take place between factors. And if that's the case, then if you do one factor at a time, you're not going to know. But if you build this design so that you can look at the process space rather than just one line, you are doing yourself much better with the experimentation.
Yeah. So I guess DOE, and I am so rusty on the DOE methodology. I mean, I learned it outside of the context of Six Sigma, statistical, engineering practices. But so it as you're jogging my memory, or is it fair to say DOE is like kind of a smart and deliberate way of trying to tweak different variables at the same time?
Exactly. That's a great description. So you want to essentially look at anything that might impact the response variable that you're looking at, and then vary as much as you've always got constraints on what you can use, whether it's resources and in my case, I might have limited wafers that I can use, or limited optics that I can use for developing a certain type of process. So I would need to choose factors that I knew were the most important.
Mm-hmm. So I want to talk a little bit about the upcoming book. And when you had told me about it, my eyes lit up, because I love talking about mistakes, and mistakes might lead to failure, and we might have other causes of failure, and trying to think about how we brace ourselves for failure or react to failure, especially in experiments or improvement or innovation. And again, the book is Faceplant: Free Yourself from Failure's Funk. And there's another connection to a previous podcast guest. The introduction is written by Wendy Smith, who was my guest in episode 507. So I'm going to ask kind of a similar origin story question of how that book came to be.
So Faceplant came out of, I decided that I was interested in this idea that I could, in my own life, I felt perfectly comfortable working in a lab and failing, running an experiment where all of the experiments failed. And I knew that I would learn and grow as a result of it, because I'd be able to still build a model, and it would point me in a direction that I could, and I'd be doing great. But then there were other areas of my life where I was really stuck, and I didn't want to take a chance on failing. And so I was like, well, why is that? Why do I feel in my professional life, I feel like I can take all these chances, but in my personal life, I'm afraid, and I don't want to do that.
Mm-hmm.
And so I started a big experiment, and then as a result started reading a lot about failure, and from your book and from Amy Edmonds' book, and started reading all this stuff about failure and exploring it. And I spent about a year really looking at it and going through it, and then I reached out to a couple of colleagues and said, hey, I'm interested in exploring this. And the two of them were like, absolutely not. That sounds awful. Why would I want to look at that? Why would I want to talk about that?
Yeah.
But anyway, after a while, I was able to convince them that this might be something really valuable for us. And so that's how it got started. And they were, after the first few sessions of tears, where we were talking about our failures that we had in our lives, they were pretty convinced that there was something there for us to talk about.
Yeah. Well, on that theme of designing experiments, or what Amy Edmondson refers to as intelligent failures, I think there's this balance. I think it's interesting to find the balance of not being so afraid of failure, but not being unnecessarily risky, right? So is it a matter of, like, does a well-designed experiment include, the idea of like, well, how do we fail on a small scale so that we learn from it?
That's one of the things that I think makes it is a great way to start learning about failure, is to design these tiny experiments and be really open and curious about what the results are going to be. So not having some preset end state in mind, like really just being open and curious about, well, what is going to come out of this? What is possible? And that really opens you up to then being able to take chances
Hmm.
and not being afraid then to fail, because there's a way that we can recover from that,
Yeah.
right? Like that it doesn't have to be the end all that, oh, I'm going to be, banished to my closet for the rest of my life because I failed at this thing,
Yeah.
which was what happened with my first attempts to speak a foreign language.
Was that a failure, or you feared
Oh, it was an
failure?
awful failure. It was an awful failure. It was terrible. I was so embarrassed. My it turned out a friend of mine. I showed her. I was taking my first Spanish class, and I showed a native Spanish speaker. Hey, here's my. I was so proud of this report that I'd written
Yeah.
in Spanish, and she looked at it and she's like, "This is like a third grader or a first grader," and I was humiliated. And I was like, okay, well, I'm not going to go back to Spanish. I
Mm,
can't do this. I'm not
yeah.
going to, and this was as an adult. I was 40 something years old when I did that.
And so you brought that funk upon yourself.
I did. I
Yeah.
did. So, and it, sadly, it's that way for many of us, right?
Mhm.
Where we, in certain areas of our life or certain experiences, they resonate, and we're just like, oh, it's awful. And so we get caught up in that kind of the funk of those emotions that really drag us down, and then we're like, oh, I'm not going to take any more chances. I learned my lesson. I'm not doing that again, right? And maybe that's not the lesson we should have learned from that.
Yeah. I mean, the surest way to never fail is to never try anything
Right, right.
new or difficult, or right. Well, I'm looking forward to that book very much. And I'm going to try to tee you up. Hopefully, you can come on the My Favorite Mistake podcast, whether it's your Spanish your attempt to learn Spanish, or a story, from your career. I think that would be a great audience to come talk about faceplant with as well.
I'd be happy to. Happy to. Yeah.
Yeah. Well, thank you, Melissa, for joining us and sharing your story and some of the lessons learned along the way. Again, our guest today, Melisa Buie. The book available now is Problem Solving for New Engineers. I'll put a link to that in the show notes, and then upcoming book November. You think, or at least that's the
November,
projection.
end of November.
Faceplant, free yourself from failure's funk. That's kind of fun to say.
I usually get tripped up.
There is risk of misspeaking and
Right.
having to bleep. I was trying to be pretty careful on landing that one. Failures funk.
Right. Right.
So,
Yes. Well,
Melissa,
thank you, Mark, for having me.
yeah, thank you.